Okay, so in the last little 10 minutes or so, I just kind of blew through all of the weeks, so you can check that out later. Energy storage inventory. I'll just read through week 1 with you. This is really, this is Al Frazier's bio. Close enough. He lives in Eugene. He developed the course. He's a practicing, he's a licensed professional engineer, just as I am, and he just does power all day long. All day long. So PV, right? You want your PV, but you're not always using it when your sun's shining. Power quality we'll talk about. That's the power factor correction device. Demand response, sometimes you'll have different pricing depending on time of day. That has not come to Montana yet. And then what's coming up in the future when the EVs really either suck or supply electricity. Okay. Now, we do build our own models in Excel. We'll sit down, and in each one of these problems, you really want to sit down, pencil, paper, 101, pencil, paper, get it correct there first, and then put in Excel. We're trained to think better with our, hand actually touching the paper, work it out. Once you've got that, okay, now I'm ready to go into Excel. And Excel will not argue with you. It'll just spit out the wrong answer if you didn't program it right. It'll just sit there. So, and I found also just taking your time and making nicely formatted spreadsheets pays off too. It's hard enough to read someone else's code, but even reading your own sometimes is tough if you don't kind of stay consistent with the format. Okay.
So there's something that's formatting the sheet.
Yeah, one trick on formatting is to put the problem statement on the Excel spreadsheet in a little text box, because then you can because all the little data, all the numbers are in there, and you're gonna be pulling the numbers out and making sure they're right. When you turn things in, so use your input and output cells. So this is where the information goes in, somewhere else it comes out, color coded however you like. Having the title block on there, because there'll be a few problem sets where you'll have sort of problem 1, problem 2, so you can just see what it is in English. And again, once you've got the answer, then put a little more time in formatting it so that again you come back to it and you get it. And yeah, everything has to be driven inside the spreadsheet. There's no real human in the loop here, if you will. There will be a few if statements. So if cell A1 is greater than B1, then 0. So play around with the if statement a little bit. Also play around with the significant digits. I don't want to see 17 sig digs. We can format that. So we'll be using horsepower sometimes and feet and inches, which, okay. But then there'll also be some SI for electrical, kilowatt hours, megajoules. Okay, so there's a little deal here, how to do your spreadsheets. Get your PDF going. Make sure your machine's not going to crash. Back your stuff up, put it on a memory stick, email it to yourself, email it to your grandma. Whatever you gotta do.
Put it in the cloud.
Yeah.
UM box.
UM box.
UM box is really good. Yep, use that. Okay, this is the first assignment. First assignment is to list at least 10 things in your house: battery, hot water tank, fuel in a nearby vehicle, then some food in the fridge. So you got chemical, thermal, chemical, and I guess chemical again. What was that what I was saying? I mean, chances are you don't have a flywheel in your house doing energy storage. If,
Air pressure.
if you want to do your bike, yeah, if you want to do bike pressure tires, you could do that. People do that before.
I got all kinds of it going on. I live in an apartment building.
Yeah. Okay, now let me see if I can't just pull up an example of what this guy is going to look like. Week one's pretty simple. Yeah. So here's Bauer. So he had 10 separate tabs. You could put it all in one tab if you wanted to, but he kind of got in a groove. Water heater. And here, so these are input slides, input spots. 50, water out. And so at the end, his solution is just the product of those four numbers. The change in temp, let me see where he got that. Now, here's what he kind of did wrong, I guess, in a sense. This should really equal, so here's your first calculation, equals dink minus dink. The answer's the same, but really this cell,
That would be an output then, wouldn't it?
yeah, or just a calculator. It's an intermediate, something like this on a conversion factor. So these guys are really your four inputs, aren't they? Yeah. So input, calculator, conversion factor, answer. And I don't know if he actually got the right number. Yeah, because he didn't. So this might not even be the right answer, but if you see here, heat capacity of water, you actually have to have BTUs per gallon. What exactly? So he's missing BTUs per gallon. So this answer is actually incorrect. It's nicely formatted, but unless there's 1 BTU per gallon per degree Fahrenheit, which it's not, because it's a BTU per pound per Fahrenheit. So his answer's off by a factor of 8, because there's 8 gallons in a pound, 8 pounds in a gallon. Okay, but good formatting.
Doesn't sound right.
What's that?
What, 8 pounds?
There's 8 gallons to a pound.
Sorry, I said it backwards. 8 pounds in a gallon.
Okay.
Yeah,
That doesn't sound right.
Eight pounds of water in a gallon.
Okay.
Because there's a pound a pint, and there's 8 pints in a gallon. Okay, so here's gasoline, 8-gallon tank, BTUs per gallon. And again, I might suggest that you just leave these blue. They're not really inputs, they're just conversion factors, input values. And you can come up here and say, okay, these are conversion factors.
So there is specifications of the colors then? Or just-
These are just mine, I'm just,
Oh,
you
gotcha.
use what works for you. I mean, there's
Okay.
probably someone out there who's like, I can't see the difference between green, but.
Just
you-
make a legend.
Yeah, there you go. So now you can go back and see it very quickly. So can someone easily seeing it. And this is probably too many significant digits, so I'm just gonna do Control 1.
You can also just go right up there in your taskbar, do it.
Oh, can I now?
Look. Up there, where it says general, in the middle, see the dollar sign, percent sign?
Oh, this guy?
Well, you don't
Oh, you
need
just
to
click
do
it right and left. Oh, cool. Okay, yeah, sweet. I like that, I like that. So the point here is to then say, well, I've got 8 kilowatt hours, probably not correct, but you can then sort of go across the board and say, gosh, you're comparing apples and apples, basically. You know, you're comparing energy in values of kilowatt hours. Battery, 12 volts. There's your amp hours. There's your watt hours, and then he just converts it to kilowatt hours. Watt hours. This guy would be more of a calculated. Again, I'm just using gray because it's, you know, so I'd come up here and say, you know, calc. And that way you're like, these are the only two, I mean, you can't really screw those up because you're putting the numbers in, but at some point you're like, I made a mistake somewhere, where is it? Is it in my green? Am I off by 2 orders of magnitude? Did I put an extra 0 in? Did I like divide when I meant to multiply? And there's a million different things that can go wrong, but keeping it consistent. All right. Calories per serving, let's see, oh, block of cheese. Okay, calories per serving, 8 servings, joules per calorie. Again, I might go and say this guy's a blue, kilowatt hours per joule. This is a blue. You know, then come back here and say, okay, this is my copy, food, paste. You know, and probably what you do is just have, I guess if you're gonna like really nail this thing, you'd say, you know, and just keep tweaking it, and then, or just answer. Answers in yellow. Right, and then all these guys can come in here. Get them all centered, however you like. Little notes. Mickey probably, yeah. But, you know, the easiest thing is like, okay, now I can see that guy, it's just, oh. Yeah. Well, here's what, you know, if I were just gonna, there's plenty of space here, right? I'm just gonna take both of these guys and just drag it right over there. Same answer. I didn't have to do a dang thing, and then I just come back. Outside borders, fine. This guy was calculated. Okay, now we're getting somewhere. And I think this was also entry, right? So there you go. So you put these two in, this gets calculated, there's your two conversions. Boom, pretty simple. Another thing too, let me just show you this guy, equals product.
Kind of like a sum function.
So, yeah, it's exactly like the sum function. Let's see how Shauna's. Ding, ding, ding. That's kind of fun. Yeah. So, there's a little trick. Let's see, firewood. Pounds of dried wood. These are conversions. And again, you can just come up here, copy 3, firewood, paste, drag this guy somewhere else. Fine. Fine. This double click thing's pretty handy. Double click, 250 BTUs per pound. So these are also, again, conversion factors. Get those guys, whatever. I just keep picking blue because it's easy. See what his is. And then, again, you can just do, equals product. And this is also where you're going to want to be sitting down with your pencil paper, writing this out with, pounds in the numerator. Now it's in the denominator. Pounds and pounds cancel. BTUs in the numerator. BTUs in the denominator. BTUs and BTUs cancel. And you're just left with kilowatt hours. So sitting down, pencil paper is going to help you through this. Propane, same deal. Basically it's firewood, just different numbers. Gabbage. Yeah, there's your gabbage. Which, again, is just chemical. Here's potential, what do you do? Potentially a 50-pound object. I don't know if he's rolling boulders downhill or whatever, but it's a good comparison. I mean, look how little energy is in a 50-pound object 10 feet up a hill. It's not going to heat your water tank rolling that bad boy down the hill. It's not going to charge your battery. It's not going to. It might chop a piece of firewood. I mean, you drop a 50-pound weight, 10 feet. You might chop a piece of kindling with it, but. He's got a little typo. He misspelled capacitor, but happens. Okay. This is a good one. Half of the initial voltage. So, yeah, coulomb of charge, volts. Yeah, that guy's a conversion factor. That's right. I do not remember the formula right off the top of my head for joules in a capacitor. Let's just go look that up. So that's where having that equation might be handy here. One half Q squared C. I'm not sure you got that right. One half. Q's charge. One half CV squared. It looks a little bit like the kinetic energy equation, one half mv squared, doesn't it? Yeah.
The
Let's just check this out really quick. Classic, counterintuitive elements. To be sure. Charge times voltage. Half of the energy is dissipated in the heat in the resistance of the charging pathway. And thus only, really? Thus only QVB start, okay. The counterintuitive parts, we say that's too much loss to tolerance, going to lower the resistance. Energy, IR squared. So if you're charging your capacitor, it charges very quickly initially, and then it slows down. Has Wally talked about this?
A little bit,
Yeah.
Yeah.
It's sort of like if you wanted to fill up the room, you could run in and fill it up very quickly, but then those last few seats, it takes a little longer to find your seat and all that. Okay. So,
That was more resistance to get through.
yeah.
I think Wally used the staircase metaphor for it.
Yeah, it's a good visual. Okay. Yeah, so this little so Q is the charge, and when you integrate that, it goes squared, and here comes your half. So 1/2 Q squared C. 1/2 Q squared C, or, well, he used voltage, though. What's the relationship between? Okay,
What size capacitor is he using?
he is using a 4 coulomb capacitor.
That's using microfarads.
Yep, that's right. It will be in farads.
Capacitors are microfarads.
Yeah.
Not coulombs.
Oh, so he's got a different formula. So there might just be. Well, I'm not going to burn any more electric time on it, but that wasn't the point. But yeah, I'll have to look into that guy a little bit more. I just do not remember the formula off the top of my head. It's not intuitive, but okay. So that's what you're doing for assignment 1. That's what you're doing for assignment 1.